All right, we're doing lesson 17-1, which is on dilations. Dilations and then similarity transformations. So, for the sake of time, I went ahead and answered question number 1 and number 2 right here on the picture. Question number 1 says, what are the coordinates of layout A? Question number 2 says, what are the coordinates of layout B? So I put those on there. Question number 3, what relationship do you notice between these coordinates? 0, 8 compared to 0, 4. What do you notice? What do you notice from the coordinates 6, 8 to the coordinates 3, 4? What do you notice? 0, 0, 0, 0 didn't change. 6, 0, 3, 0. I don't know about you, but what I noticed is that all coordinates, I'm going to abbreviate because I'm too lazy to write the whole word. All coordinates are half. All right, so that's what I noticed. And then question number 4 says, well, I guess we could have said all coordinates in B are half of A's. That's a little bit more clear. Okay, so go on to question number 4. It says, express the transformation in item 3 as a function. Well, you know the notation that they've been using. They've been using this notation. If x, y is the point in the pre-image, that's going to transform or change or map to, what do we do to each one of them? We said half of x, comma, half of y. So that's what they want for the answer to number 4. Sorry, that was my timer that says, get up and move, because I've been sitting in my chair too long. I'll finish the video first, though. Okay, so the next one, we move over here, and we look at layout C. And they want us to write the coordinates down. Well, the coordinates here are 0, 16, and the coordinates here are 12, 16, and the coordinates here are 12, 0, and here we're at 0, 0 again. Do you remember what they were for A? So here they were at 0, 8, and then 6, 8, that was A, and now for C, they're at 0, 16, and 12, 16. I'm going to write down for layout A. They were, A was at 0, 8, and B was at 6, 8, and C was at 6, 0, and D was at 0, 0. So that's where they were. And now it went from 0, 8 to 0, 16. It went from 6, 8 to 12, 16. It went from 6, 0 to 12, 0. So question number 6 says, what do you notice when you compare the coordinates to layout A to the coordinates of layout C? Well, for the answer to number 6 is we notice that if you take the coordinates of A and double them, you get the coordinates in C. Okay, so right, 0 times 2 is 0, 8 times 2 is 16. 6 times 2 is 12, and 8 times 2 is 16, and so forth. So, and then question number 7 says, express the relationship as a function. So in other words, if we want to take any ordered pair that's on the pre-image and transform it to an ordered pair that's going to be on the image, which is C, then what do we need to do? We need to double it. Okay, now the question down here says, all right, pay attention to this vocabulary word. Dilation is a transformation that represents a change in size. So we're changing the size of the figure. We're not changing its shape. A rectangle stays a rectangle. A triangle will stay a triangle. But we're changing its size. And how much are we changing its size? We're going to describe it by a factor of some number. So the scale factor is going to determine how the size changes. Now, did you notice that when we went from layout A to layout B, what did the size do? The size changed, but B is smaller than layout B is smaller than layout A. So that means that we would answer this question down here. We would say that what is the scale factor for the transformation? So we already said that it halved, right? So I'm going to say K, and that's probably not the best way to write it. This is supposed to be a lowercase script K. That's really ugly too. Let me try again. There we go. So that's a K. The K is 1/2. And then it says, is layout B a reduction or an enlargement? It was a reduction. It got smaller. Then it wants to know what's the scale factor for A to C. Well, A got bigger. We doubled its size. So the K value was 2 because that's what we did. We double it. And we learned that it was an enlargement. Okay. Now on the next page it says, in general, what are the values of the scale factor K that's going to make this dilation be a reduction? Okay, I'll show you what the Springboard book has, and I would doubt very seriously that any of you would have written it like that, but you should get used to it because this is very, very algebraic, and this is going to be something that you're going to see. Let me rewrite that because it's kind of ugly. It's going to be something that you're going to see in Algebra 2. So 0 is less than, that script letter K is less than 1. And basically what they're saying here is, let's translate this to a sentence. This says, the value of the scale factor, and again, I'm not writing it all out because I'm going to run out of time. The value of the scale factor on a reduction will be a number between 0 and 1. Now think about what kind of numbers are between 0 and 1. Well, some of you, if I ask you, make a list of some numbers that are between 0 and 1, most people are going to say 0.5. And remember, 0.5 and 1/2 are the same value. So yes, 0.5 is between 0 and 1, and so is 1/2. Well, what about 0.2? 0.2 is definitely between 0 and 1, and that is a value of 1/5. Okay, 0.25, that has a value of 1/4. So these are all examples of numbers that are between 0 and 1. These are decimal forms and these are proper fractions. And the reason that I say, so when you say, what is K going to be? K is going to be, I'm going to say a proper fraction or a decimal. And by decimal, I mean between 0 and 1. So this is what, when I see this right here, the first thing that pops into my mind, oh, they want a fraction, or oh, they want a decimal. Now I said proper fraction because 3/2 is a proper fraction, but the value of 3/2 is 1.5. That is not in this group right here. This is not a reduction. This is not going to make, it's a fraction, 3/2 is a fraction, but it's not going to make it smaller. And the reason that I'm saying that is because in just a second you're going to be asked to do this scale factor, and with this scale factor right here, 5/2, it's a fraction, but is it a proper fraction? No, that's a value of, I think, 2.5. So that's not going to be a reduction. So it says here, in general, what values will the scale factor be if you want the dilation to be an enlargement? Well, in that case, K is just going to be any number greater than 1. And I did a capital K, so let me do a lowercase k. K is going to be any number greater than 1. So numbers bigger than 1, fractions or decimals, will cause an enlargement. Numbers between 0 and 1 will be reductions. Are we going to have a scale factor that's negative? No. If you have a scale factor that's negative, you remove the negative, and the negative causes a reflection, and then you do the scale factor as a positive number, and it will enlarge or reduce. Okay, so number 11 says, let's take this point right here, which is a pre-image, and it says we want to, how would you find the coordinates of the image after a dilation with a scale factor of k? Well, what did we do a while ago when we had a scale factor of 1/2 and a scale factor of 2? We multiplied by k. What did we multiply? Each one of the coordinates. Multiplied by k, each coordinate. Okay? So express the relationship in item A as a function. So what do they want? Well, they told us specifically that this ordered pair was on my pre-image, so they called it AB this time. AB is going to transform into or map onto K times A, and then K times B. You take each coordinate and multiply it by K. This is just the symbolic way of saying exactly what we said right here. Okay, so real quick, I hope my video is not going too long. I have taken this information right here and I've moved it over here to this other program, so I'm going to jump over here. But you should have those coordinates put down. They want us to change the coordinates with the transformation and then dilate it. So that's called a composition. Anytime we do more than one transformation to the original item, that's called a composition of transformations. So they want us to first translate it and then follow with a dilation. Now we see the scale factor is 1/2, so we know that that dilation is going to cause a reduction in size. So I'm going to go here. I have, like I said, I have all of this laid out. I went ahead and wrote down, this was the transformation that they asked us to do. So this is what we have to do first. We have to do this transformation, and x minus 4 and x minus 6. There's two ways to handle that. We can do it, I'm going to do it this time. I'm going to take this triangle, or this rectangle, sorry, and I'm going to translate it left 4 and down 6, because that's what subtracting 4 from x would do. So there's translating it 1, 2, 3, 4, and then I'm going to translate it down 6. 1, 2, 3, 4, 5, 6. So now that I've done the translation that it wanted me to do, all I have to do is look at my ordered pairs and see where they are. Look at my vertices right here and see where they are and write those ordered pairs down. Now you can certainly do that. This is, this is A prime. This point right here is B prime, and this is C prime, and this is D prime. So when you write down the coordinates of A, you see that A is now located at 1, 2, 3, 4, -4, 0. Before I go and do the rest of them, I also want you to notice, though, that if I took this ordered pair, which was the original one, and I said 0 minus 4, I would get -4. And if I said this 6 right here, this 6 minus 6, I would end up with 0. So you should be able to get to it both ways. Move the figure and then see where the new point ends up, or you can do the arithmetic on each figure and then see where it ends up. So 4 minus 4 is 0, and 6 minus 6 is 0. So it says that B prime right here should be at 0, 0, and it is. And then 4 minus 4 is 0, and then 0 minus 6 is minus 6. So C is down here at 0 minus 6. And then, of course, D is 0 minus 4 is minus 4, and 0 minus 6 is minus 6. So D is down here at negative 4, 6. Now, that's the first translation. Now, we've got to follow that by a dilation. And so I'm going to take each one of these images, each one of these ordered pairs, and I'm going to half them. So half of negative 4 is negative 2, half of 0 is 0. Half of 0 is 0, half of 0 is 0, half of negative 6 is negative 3, negative 2, and negative 3. So I halved them. So if you go over here and plot these points, and I'll plot them in blue, you've got the point negative 2, 0, and you've got the point 0, 0. This is A prime prime. And then you've got 0, negative 3. That's C prime prime. And then you've got negative 2, negative 3. That's your D prime prime. Okay, so that's calculating the coordinates algebraically, or using, your rule. And if you want to see it transformed, then it has originally a height of 6. And if we half it, that will make it be a height of 3. And it originally has a width of 4. And if we half that, we'll get a width of 2. And then we see our final answer. Now, if you're actually answering the question that's in the book, this group right here are your answers, because they ask you for the coordinates of the second transformation. So the image that resulted from the second transformation. So these are your answers to number 12. I'm going to go ahead and stop the video. I see that it's running on 16 minutes. So we will start the next video with me providing you with the answers to the Check Your Understanding.